Alright, this is part 2 to methods to simplifying and solving with log expressions. Here are some of the properties again we're going to use. Condense back to a single logarithm. Use your converting to an exponential, or use your inverse or one-to-one properties. This is just part 2 of some of the problems that we've already done. Alright, so we have two logarithms and we want to simplify this expression. So what I like to do every time I simplify something is I like to throw just an x in so I don't have to reduce it. Alright, so one of the properties we can do is we can throw that 2 back up on top. So it's logarithm base 5 of 25 squared. Alright, I'm going to throw a big bracket there and I'll show you in just a moment. Minus a logarithm base 4 of 16. Alright, now let's take this bracket here and we want to use our inverse property. So I'm going to say take the logarithm base 5. I'm going to change that 25 to 5 squared. Alright, if you notice those two are inverses of each other, so we're left with that whole thing just being a 2. Now we still have this 2 out in front, so we still have 2 squared, which gives us 4. Alright, now let's head over to here. Let's simplify this logarithm. We can use the inverse property again, so a logarithm base 4 now, and we have 4 squared. 4 times 4 is 16. And when you have a exponential and a logarithm of the same base, they're inverses of each other, so we're left with just a 2. So minus 2. I'm going to bring that minus 2 down. And remember, these were equations, so equals x equals x equals x equals x. So 4 minus 2 gives you an answer of 2. Alright, next problem. We want to use maybe converting to an exponential to help us to solve. We haven't done one of these yet in this video, or the previous one. So we have a logarithm base 3. And what we can do is we can convert it back to an exponential. So when it's a logarithm base 3, its exponential will also be base 3. Remember, this 4 pops up as its power and then equals x. Now you can just say, what is 3 raised to the 4th power? So you take 3, raise it to the 4th power, and you get 81. All right, head over this one. You can do the same thing again. You can raise 5 raised to the x equals 125. Now we say, they're not equal yet. We can use our one-to-one property in just a moment. So I'm going to say 5 raised to the 3rd power is 125. Now the one-to-one property says these are equal, and those must be equal. So x equals 3. Next problem, simplifying or solving this expression on the right-hand side. We have 25. So I'm going to change that 25 to an exponential base 5. So I have 5 squared. Now I have done this problem similar in a different video. What you can do is you can take a power to a power and multiply those together. That is now 5 raised to the 4th power. Now we have a logarithm base 5, an exponential base 5. If you remember, you're left with whatever that power is. 4th power, that is your inverse property. All right. Now we have a logarithm on the left and a logarithm on the right. We're going to leave it like that, but we're going to bring this number 2 up. Remember, when you have a multiplier in front of a logarithm, you can change that as a power. All right, and I'm leaving the right-hand side alone. I'm trying to find out what x equals. Well, we can use the 1 to 1 property. It says if you have a logarithm base 3 and another logarithm base 3 equaling each other, then these two guys equal each other. So I'm going to drop it as a logarithm on both sides and solve it for x. Now this is going to be a quadratic equation. Probably the easiest way is to try to solve by undoing. You could FOIL out the left-hand side and then factor it and have some fun with it. But the easiest would be to solve by undoing. So to undo the squared, we're going to square root both sides. Don't forget the plus or minus on the right-hand side. The left side will undo to be x minus 4. The right side will be plus or minus 2. And then we're going to add 4 to both sides. So 4 plus or minus 2. All right. Now, we have two solutions possible. X being 4 plus 2 and x equaling 4 minus 2. When we simplify that, we get 6. Or we can have 2. So sometimes you might get two solutions. Not the most common, but it can happen. All right. So here are a couple more logarithms. What's different about this problem than the previous one is we have two logarithms here. We got to combine them back together into one, so then we can use the one-to-one property. So I have a logarithm base 4 plus another logarithm base 4, and as an operation of plus, so to combine them back together, we multiply. So we have a logarithm base 4 of x plus 3 times x plus 3. And we're going to leave the right-hand side alone. All right. Now, notice these two are the same, so I'm going to combine them into x plus 3 all squared. So it's x plus 3 times x plus 3 is x plus 3 all squared. All right. Now we're set to use our one-to-one property. Our one-to-one property says if we have a logarithm on the left and a logarithm on the right, and they both have the same base, you can go ahead and drop those logarithms and focus on these two pieces. So x plus 3 all squared equals 49. All right, now this becomes very similar to the last problem that we just did. We're going to go ahead and solve by undoing again. So we're going to square root both sides to undo the squared. Don't forget the plus or minus on the right. The left will be left with x plus 3. On the right, plus or minus 7. Now we're going to go ahead and subtract 3 to isolate the x. And now we're going to go ahead and find our two solutions. All right, we have x equals negative 3 plus 7, which is 4. And x equals negative 3 minus 7, which equals negative 10. Now I want to stop there for a moment. There causes a problem when you have a solution when x equals a negative. Right there and right there, if you plug in a negative in for x, we can't have a negative x solution when it's a logarithm because there's a restriction on its domain. This one will not exist because it has to have a number greater than 0, a positive number. This one doesn't exist because the domain has to be the x values greater than 0. So we only have one solution. All right, we're almost done with this. We're going to go on to the next problem. We have a logarithm on the left and a logarithm on the right, and they are both of the same base. We can use the one-to-one property again. We're going to set this and this equally to each other. So we have x minus 3 over 6, and then 3 over x minus 10. Now we're going to go ahead and use Ross multiplication to solve for x. So we're going to take x minus 3 times x minus 10. So there's the first cross. I'm going to multiply it, 2 equaling 6 times 3. All right, this one's a little more challenging. If you remember, when you have quadratic equations, you have to factor. You have to distribute this out and factor. It's already in factored form, so this is going to equal 18, and that's going to equal 18. So we have x minus 3 equals 18, and x minus 10 equals 18. All right, so let's go ahead and solve this first one. So 18 plus 3 is 21, and add 10, 18 plus 10 equals 28. So you have two solutions.